oil, vacuum, floor rolling, cassette type, small breakers. If you see, there is these breakers were withdrawable breakers. All you use in your substation are withdrawable breakers. Why? Because you want to check the interrupter condition. So you want to withdraw this. But after the vacuum interrupters became very isolated on this breaker and don't need to withdraw it. So then this gave birth to fixed breakers. These are called fixed breakers. They were very compact, 1/3 of the size, and this you fill SF6 gas and then if nobody talks about safety, then obviously they lack safety, old breakers. Are you getting my point? So, when nobody talks about safety, standards talk about safety. So therefore, IEC, International Electrotechnical Commission, they are the governing standards and they talk about safety. Why? So this you can't make anything which is fail-proof, but you can definitely make something which is fail-safe. This was the driving point of international standards. So the earlier standards changed very slowly, the new standards changed very rapidly.
Certainly are very safe. It's very important to understand the difference between the two. In Indian railways, in older times, the brakes used to work based on vacuum. This meant whenever the vacuum failed, the brakes would also fail and the train won't stop. In today's train, the brakes are held in open position using vacuum. This implies that when the vacuum fails, the train shall automatically stop. All of us agree that a vacuum failure resulting in stopping of a train is much better and safer option than the train not stopping at all. In electrical industry, the failures could be disastrous.
So far, I hope you have understood. The vacuum was used for applying brakes in old trains. What happens, you see in cowboy movies, they cut the vacuum, then what happens? Train cannot stop. If you keep the brake open using vacuum, now if somebody cuts the vacuum, the brake will fall on the wheel and stop the train. So this became fail safe. Same way, in switchgears, look.
Impact of the failure is so severe that one has to see it to believe it.
This is 40 kiloampere arc handling, and you see this power. What we are doing here is we are creating fault inside the circuit breaker, and this black color cotton is representing an operator. If these are very sensitive cloths which are made in Switzerland, which catch fire, even a hint of fire. So if these cloths don't burn, the switchgear is safe. These are all safety tests we are doing. But this is enormous power, as you can see. To look at this mushroom cloud, it looks like a nuclear bomb. It is so powerful. This is actual video of
As any industry evolves, it becomes more and more aware of the hidden dangers and ways to combat it. The earlier versions of car did not have the safety guard or airbags, whereas any modern car can't do without it. Similarly, the international standards governing the medium voltage switchgear have evolved over the last few years, especially since introduction of new versions 62271 series in 2003. These new standards are more oriented towards simulating and testing in real-time conditions and installations, practical usage, and above all, the safety of the operators has become the highest priority. These changes dramatically affect the customer and even more the operator. Let's take a few examples of these changes to see how it affects the safety of the operator. In the older IC, it was required to perform the internal knock test to see if the enclosure keeps the operator safe. However, the flaw in this requirement was that neither it was simulating the actual installation condition, nor it was testing the worst condition. In reality, the switchgears are not placed in a room whose ceiling is as high as shown in this video. Actual studies indicated that during knocking falls, inside medium voltage switchgear, a huge ball of hot air gases is created, and the enclosure should sustain the enormous pressure applied by these gases. This withstanding of pressure by enclosure saves the operator from facing the fire, so it's nice, but not enough. The life of operators is still endangered due to the reflected hot gases from the roof in actual installations.
The meaning of this is that standards gradually evolved. Earlier they were not asking for any tests, gradually they started to ask tests. But these tests were performed by switchgear manufacturers in not real life condition. So the standard made it mandatory that you must recreate the real life situation and do the testing. So the meaning is that the older switchgears were not safe. The newer switchgears are safer. But if you go around Kuwait, who's more populated, Mr. KK? Old or the new? Definitely you have more population of old switchgear. And old switchgear is not safe. Then more number of people are dealing or exposed to something which is not safe. So what to do? Very simple. Change all old installation and put new. But that's not so simple. Because of operational reasons, because of critical supplies, then what to do? Smart retrofitting. How? You can bridge the gap between old and new. See, this is common sense, nothing great engineering or technology, this is basic. Instead of asking the operator to stand in front of the breaker, you give him a remote trolley, meaning instead of standing here, he stands here. This is the operator. With a remote, he is actuating this breaker. So if anything goes wrong here, this guy is safe. I can do that, no? It's very simple. Not a rocket science. I can make a small trolley and save a person. Why not? How much will be the cost of this kind of change? Nothing. Why don't I do that? This is the question we should do. Why not? Because if I have to do this breaker and I have seen that bomb blasting, so I definitely prefer this kind of a solution. What else I can do? I can make a smart door. This is a smart door. What does it do? You see, it's so simple.
If the door is open and even a small fault occurs, it could be fatal for the operator. Thus, overflow switchgears are really dangerous and unsafe from operator safety point of view. They are neither in accordance with the safety requirements nor the latest IC standards. So what could possibly be done? Is there a way to make the existing switchgears compliant to new IC requirement? Can we really make them safe for the operator? The answer is safe and. It is possible to replace the open door by a pre-assembled closed door arrangement at side. It makes the switchgear safe, therefore we call it safe module or safe end. This can be effective to any existing switchgear with minimum.
Meaning, one, I give the operator one remote tracking trolley. So he puts the trolley, goes away and does the job. He's safe. Or I adapt this kind of a module, one box inside on my old switchgears. And there is a motor fitted. I just, by a remote, I operate. Why not save my operator or myself? These are not very expensive things, or these are very simple ideas, but they can do the job.
Can the operator really save open door by calling it safe module or safe end? This can be effective to any existing switchgear with minimum changes to the breaker. With safe end, the operator is always going to be safe behind the closed door racking arrangement. Even racking is possible by motorized arrangement where the operator need not be near the switchgear at all.
You just press a button and this breaker does the job. This door pushes the breaker in instead of manually somebody doing. You see? These fellows push the breaker in and pull it out. It's quite simple. One press of button pulls the breaker in, or pushes the breaker in, pulls the breaker out. So after having seen those kind of accidents, if this door is saving my life, that's a great thing, no? Why not? So, two things I have told you for the moment. One, racking trolley. Two, this kind of module. Now this is the third thing. For old installations we can do retrofitting. How do we do that? If you go to a dentist today for what do you call that, capping, they do scanning and they send this scanning to a 3D printer which prints your crowning, tooth crowning. Same thing we do on a larger scale. How? We have a laser scanner which is like this. This blue light is a laser. So whatever light we throw, it directly comes on our computer, scanning, with great accuracy. This is the scan data. This laser scanner is done. We have taken two examples of Kuwait. We have done, and this is the scan data. Then what we do is we take our standard breaker and adapt it to the site breaker. Then we overlap them and check whether they are going to replace successfully or not. You see, this is a retrofit example. I take out old breaker and put in the new breaker. You see, this is the old breaker. The operator is putting. Open door. It's not so easy for him. And he's at risk. Why? He's going to do this open door operation. Whereas after retrofitting, this is my colleague, he is doing the change breaker from old to new. Panel is same. So this is what is called retrofitting. changing the heart transplantation. Take the old one out, put the new one in. So 3 methods you can do, and your switchgear installation will be as good as new. So these are a few examples what we have done in Kuwait. So the summary is that the standards changed in the past years. They made the new switchgears very safe. Nice. But what about thousands of switchgear? Each one of you, if you have a substation, go there, and most likely you will find old switchgears. Now you know that these switchgear, as long as they are working safely, fine. But one day, if God forbid they explode, that explosion is going to be really, really heavy. So what to do? You can take any one of the options which I presented to you. Make it remote tracking, make it motorized tracking, change the breaker, do something. Don't let that unaware or ignorance put somebody in difficulty, hazard. So we have a team of experts. Mr. Mahir is sitting here. So we can help you come out with most optimized solutions and try to make, together we can try to make substations safer, better. Thank you very much. Any questions? You can feel free to ask me. Thank you.
Hi, thank you for the presentation. In the old substation, if you are changing only the breakers, how it is helping you? The bus bar is old, the isolator is old. Again, there is a chance of explosion. Okay, and also you show the open door and closed door. When I am engaging a breaker, I am putting the breaker in this position only. I think the isolator is open and I am entering in after closing the door. Can you give some explanation of this?
Okay, that's a good question. So first, you asked 2 things. First, I'm putting the breaker in test. See, old breakers are open door switch gears, meaning you had, when you were racking in the breaker, at that time door was open. There was nothing between you and the breaker in the older switch gears.
No, I was working in this field for more than 25 years, and all the breakers I am operating is after closing only. I am sending this breaker from test to service. What I saw in Kuwait. Okay, and you mentioned you are changing only the breakers, and you are doing a safe solution.
That's the second part.
Yeah.
So first part you are lucky, I would say, because if you go to Qatar, there are about 150,000 open door switch gear. If you go to Malaysia, 175,000. All open door. Open door means, I'll show you one video, you have to push the breaker with a long rod, you press it and push it in. So you are lucky in Kuwait, you don't have those kind of circuit breakers. But in other installations in Singapore, in Qatar, in Malaysia, there are huge number of open door switches.
So you mean there is no isolator in it in your
Nothing.
Okay.
So you push the breaker in and you are directly in line of fire. Directly. So that's very dangerous. So for that we came out with those remote door or closed door operation. Even in Kuwait, we have worked in MEW substations. They are all open door switchgear. This video what I showed to you is an open door switchgear. You see?
Yeah, it's available open door, but then the isolator actually. Yeah.
No, there is no isolator. This video, if you see, I don't know where it is.
Maybe it's from a Doha West Power Station or somewhere.
Yes. These are all open door switchgear. Meaning,
Okay.
this operator, if you see here,
No problem. You can continue. Read my second question.
the second part, I will show you this. The second part of the story, what you asked is, what about the bus bars? What about the bushings? If you change the breaker, how the installation becomes safer? The answer is, which is if you talk about the car, the engine is the moving part. Whichever is the moving part, wear and tear is going to happen there. If it is a copper bus bar and there is no partial discharge, such kind of thing is not there, then there is no deterioration as such. Deterioration happens in the switching part, in the moving parts. So the breaker has a life. if it has lived its life, you don't know on which switching operation it can explode. Bus bar is not going to explode unless until there is an external fault on that. But switching can put the dangerous bomb effect into the field. So therefore, if you are doing closed door operation, in this example what was there, you saw, we changed two things. First, we changed the old breaker with the new breaker. So there is no risk of that switching explosion happening. Two, from open door we put it closed door. Now you bolt the door and right in the breaker. In Doha West, right? Doha West Power Station, we did that. There are many examples, this is one. So the idea is the operator is now safe. Behind closed door, thanks to that, and with the new technology of breaker. Because old breaker has lived its life. You don't know which day it is going to give you trouble. So this was the explanation. I hope you understand.
Yeah, I got it, but changing the breaker definitely will increase the lifetime. But when the aging is happening, okay, the recent cases in Kuwait, okay, I see the partial discharge is happening in the bus bar insulators, and there we had a flashover also 1 week before in one of the substations. It is not in the breaker compartment itself. That is for this question actually.
Right, I understand. I appreciate your question. So the point is, each case has to be studied. Where are the vulnerabilities? Where can the failure be? If it is, partial discharge or those kind of failures don't happen in one day. They show clear signs. They show humming. They show tree. There is a tree structure like lightning strikes. There is a tree.
Yeah.
On the epoxy parts, you can see there is a tree. There is humming noise. So these are the symptoms which experts have to catch and then make sure that the installation becomes safe.
Thank you. Thank you for asking. Thank you.
Anything else? Thank you very much for the question here. Thank you.
We sincerely thank Mr. Amith for his insightful session on enhancing safety of old medium voltage switchgear as per the latest INC norms. So, your expertise and practical guidance have provided us with a deeper understanding of upgrading legacy systems while ensuring compliance with the latest safety standards. We truly appreciate the time and effort you took to share your knowledge with us today. It is now time to felicitate our distinguished speaker. Before felicitating our speaker, I request Mr. P.T. Muthu, Vice President Mr. Gargam, Mr. Staff General Secretary, and President Mr. Rajendra Kanan to kindly come onto the stage. May I invite Mr. P.T. Muthu to felicitate Mr. Amith with a shawl as a mark of our respect and appreciation. May I invite Mr. Raghuram to felicitate Mr. Amith with a garland as a mark of our gratitude. May I invite Engineer Stanley and Mr. Rajendra Kanan to felicitate Avanish with a memento in recognition of his valuable contribution. Thank you, sirs.
Hello, sir. Hello. Okay.
May I invite Mr. Mahboula, Country Manager from Eaton, to kindly come onto the stage. May I invite P.T. Muthu to felicitate Mr. Mahboula with a shawl as a mark of our respect and appreciation. May I invite Mr. Ram to felicitate Mr. Mohammed Salama with the garland. May I invite Mr. Stanley and Mr. Rajendra Kannan to felicitate Mr. Mohammed Salama with the memento.
Hello, sir. Hello.
Thank you, sirs. Dear all,
I just want to say thanks to my college mate, Sudhanshu. He has come from Spain and Sudhanshu, can you please raise your hand? He is my best friend. He has come from Spain and just for this session, he was kind enough to encourage me to stay back. Thank you, Sudhanshu. I appreciate that. Thank you.
dear all, we now move on to our next session titled Auditing and Assessment of Infrastructure and Building Utilities, presented by Mr. Kalaimuri from Amith Civil and Allied Engineering Services Private Limited. Through this presentation, participants will gain clarity on key audit parameters, common deficiencies observed in existing facilities, and the importance of integrating audit outcomes into the sustainable asset management strategies. Before we move on to the next session, dear participants, please note that the kits are available at the Mahboula exchange counter. Those who complete their new app registration may collect a wallet, and those who complete online transactions may collect a laptop app. With due respect, TEF office bearers, distinguished guests, dear members, and it is my pleasure to warmly welcome Mr. Kalaimuri, a senior civil engineer professional with extensive experience across government sector, consultancy, and industry. Mr. Kalaimuri is a civil engineering graduate with a master's degree in environmental engineering from the College of Engineering, Delhi, Anna University, and a postgraduate diploma in alternate dispute resolution from Nalasa University, Hyderabad. He is currently the managing director of Amith Civil and Allied Engineering Services Private Limited, where he provides specialized services in quality auditing, structural stability, design vetting, condition assessment, rehabilitation of structures, project management consultancy, and contract line management for buildings and infrastructure projects. He also served as a senior management consultant at Cube IIT Madras, contributing to major projects such as Amravati Capital City Development and AIMS Madurai. Prior to this, he spent over 2 decades with TAMCO working on hydropower projects and thermal power plants, and retired as an executive engineer. With his strong field exposure and practical insights, his presentation is sure to add significant value to today's technical program. On behalf of TEF, I warmly welcome Mr. Kalaimuri to take the stage to deliver the second section of the technical innovation.
Good evening to one and all. Respected chief guest who was here earlier, Mr. Dhari Al-Ajmi, distinguished my earlier speaker, Mr. Amith, General Secretary of Tamil Nadu Engineers Forum, Mr. Angel Stanley Charles, and distinguished members of Tamil Nadu Engineers fraternity. At the outset, I should convey my special thanks to Mr. Krishna Kumar. He was my classmate and batchmate. And he did his electrical engineering, whereas I was a civil branch. But we were together in the hostel from 81 to 85. So I have to extend my special thanks to him, who has invited me for this forum meeting and requested me to give a presentation or a case study for a project which I was involved all along in my service on this particular topic. So I thought whatever I share before this forum should be beneficial to all our engineers. That is how I selected a topic on quality matters, auditing and assessing of infrastructure and building utilities. I think many of you from the engineers forum should be from civil engineering fraternity on oil and gas or from infrastructure development projects. Hopefully, I think so. So now let us move on to my topic on quality audit. Why I have chosen this topic matters. Quality is a subject spoken and implemented for all types of infrastructure development. That can be an offshore structure, a substation, buildings, roads, bridges, and so on. Any development should comply to certain standards and specifications to ensure long-term safety, performance, and sustainment of serviceability. In today's presentation, I will be discussing on two of my topics, case study projects. That is related to quality audit for a development of capital city project in Amravati, and the other will be for a conditional assessment for institution building that our team has handled. So in recent years, our role of engineers has expanded beyond design and construction. Once the development of any infrastructure utilities is completed, it will be put to use as service. Then the role of audit engineers are essentially called upon after few years to verify, audit and justify the performance of existing infrastructure that are in service. As my earlier speaker, Mr. Amith, was speaking about retrofitting of switchgears that are in the existing substations. This is also a similar kind of a thing what we do in auditing and come out with some recommendations based on the study. Likewise, he was telling to replace or retrofit the existing switchgears with a new one in building as well as in infrastructure projects also. After conducting and carrying out an audit and also by means of conditional assessment, that is, we can suggest some few solution to strengthen the infrastructure and extend the serviceability of the structures. So, despite advances in design tools and construction technology, many of our infrastructures today faces with premature distress, performance uncertainty, and quality gaps that can often lead to deterioration within the first decade of service, though they are designed for safety, serviceability, and durability. So, quality audit and conditional assessment have therefore become critical tools not only for safety but for risk assessment, life cycle planning, and informed decision making. Before getting into the field study, I'll say a few words about what is quality audit and the activities that is covered in the audit and why quality audit is carried out in infrastructure or building facilities during construction phase. So, quality audit is a systematic evaluation of assets on the independent structured review of infrastructure utilities like bridges, roads, even any kind of an offshore structure or substations to verify whether in compliance with approved design specification and standards during construction phase. So, the evaluation will be on assessment of construction quality of material, workmanship, and the construction practices that are carried out as per code or quality plan given by the contractor or the EPC agency who is undertaking the work, and verification of safety and serviceability. We have to ensure that the quality utilities are capable of delivering the intended performance throughout the design life. Identification of defects and non-conformities and rectification of the same and documentation. that also comes under the evaluation of the assets. Risk and durability evaluation. It assesses the material condition, load bearing capacity, environmental exposure, and support timely strengthening, repair or preventive maintenance decisions. So all above activities helps the quality auditor a place for rectification, strengthening, monitoring and improving the quality of control measures. The real challenge is what is constructed at size truly meets the intended design, performance and durability requirements. That all these forms the evaluation, systematic evaluation of the quality audit. So why quality audit is used for buildings and infrastructure? See, infrastructure projects often involve multiple stakeholders during construction and implementation, like tight completion schedules, cost pressures, change in condition during execution, like so many physical, technical, environmental or operational condition changes occurs at the project site over time during construction phase. These factors increase the likelihood of deviations in materials, workmanship, sequencing of activities, and quality control processes. Audit provides an independent and systematic verification of compliance, helping to identify hidden deficiencies that may not be apparent during routine inspections. Audits can also transform infrastructure management from a reactive approach to a proactive one, that we have to plan, like a quality plan, we have to prepare all the plans before the commencement of the project so as to improve the quality plan, implementation of the quality plan as a proactive one. Performance-based strategy, safeguarding the public safety, optimizing the cost and enhancing long-term sustainability. So the defects and non-conformities in construction risk are detected at early stages, minimizing the rework and failures. So whatever we do or observe, all these things has to be documented. All these documents audit establish a traceability, accountability and technical justification for decisions, perfecting both asset and professionals involved at a later date. Supports durability, sustainability and resilience against environmental as well as operational stresses that we come across during the phase of constructions. So let me move on to the case study where this project I was a team leader handling with the quality of implementation on all the infrastructure works that has happened in this particular project. This has come up in Amaravati during the year 17 to 19, but for some reasons it was stalled during the middle of 2019 by the then government that came to power, but now it has restarted. So why I have taken this as a case study means the scale and volume. Actually, the project is implemented near Vijayawada in a land extent of about 217 square kilometers, roughly about 53,600 acres. It covers all types of infrastructure components like bridges, roads, culverts, drainage system for stormwater and sewerage, buildings of various categories for office, quarters, office building ranging from G plus 12 floors for the staff and G plus 40 to G plus 50 floors to accommodate the government secretaries. So the systematic audit, what we did for this particular project, supported us to take majority engineering judgments during the course of execution. So our role was to monitor the total quality aspects for all the types of infrastructure components. Actually, this project was as being covered in an external land area. Each project component package were executed by different EPC agency, and they followed their own quality plan approved by the client APCRA. That is Andhra Pradesh Capital Region Development Authority. And the method of construction was same, using aluminum for monolithic construction. And the implementing agency were finding too difficult to monitor the quality aspect of different activities executed at different locations of the project. So the role of quality team was implementation of quality systems like enforcement of plan for QAQC plans and testing plan given by the EPC agency. Our role and scope was to check only 10% of the quality check in respect of every development work. Not the entire 100% check was not performed. As there are some other agencies like PMC, site engineers were used to be there. Below us, the EPC agency who has done that entire development works, their engineers will also be there. But above all, we were the one handling with the entire minute task of controlling the quality. So, our role was to verify testing of materials supplied and used at site by original equipment manufacturers, and also we do third-party checking for the materials that was supplied by the suppliers, apart from the test reports they furnish along with the supply. Then process control for concrete and batching plants like moisture correction for local materials supply like aggregates, fine coarse and fine aggregates. And at the place of pouring, at the time of pouring the concrete, the temperature has to be maintained to ensure that the quality of the concrete is safe from the place of blending to the same place of pouring. Then we have to our team has to carry out a field inspection daily at one spot along with the PMC and EPC agency, visualize the defects and non-conformities and create a report for the rectification. Ensure that the NCR raised and defects identified are closed within 3 days by the EPC agencies, and this has to be documented for our document purpose. And senior quality auditor team would visit all packages as there were about 53 towers. And I'll move to that detail. See, this was the total project initially understood as I was actually associated with IIT Madras CUBE organization. CUBE is a Center for Urbanization, Buildings and Environment. That is an organization and with an outfit of IIT Madras. So that particular organization was interested with all these packages of work. Initially, we were interested in only first 3 packages, which has got only quarters type of buildings. All the blocks are of G plus 12 floors. But all the activities are happening at different location of the project. So initially, by the time when we were interested with the quality assurance and quality control, we employed about nearly 15 in-location engineers to make observations and take the record the observations and report to the authorities of the APCRA. The number of observations initially raised were in the range of 40 to 50 sheet per each relocation engineer. And it has become so cumbersome to handle the entire auditing process, a cumbersome process, as more of labor-oriented one, as the relocation the engineers has to be trained how to handle the observations and upload the observations. And we have by weekly and bi-weekly, we have to perform some meetings with the authorities of the project, and it has to be updated to them with the feedback. So subsequently, after seeing the performance of our relocation engineers as well as our quality team, which are executing this quality audit for the initial 3 packages, subsequent packages were awarded to us on a stage-by-stage basis. Once the on a stage-by-stage basis. See, initially the observations were handled by relocation engineer, and subsequently when the job was finding so difficult to handle by the relocation, we have automated the reviewing and reporting procedure through a web-based technology by developing a mobile application called QScan, and it was developed in-house by our Q with the support of our relocation and quality auditors. So the tailor-made application was specifically developed for this project to monitor the activities of work and to record the observation easier by the relocation engineer. I'll tell you how the application was developed and how the relocation engineer has used to make the observation using that mobile-based application. An invocation engineer first, when he visits a particular project, say under package 1, he has to first log in as a registered user with the date and time. He will be allowed to visit the project only for the work which he is assigned. So he cannot enter into the project which he cannot, which he is not assigned with. So under this, for example, under the main package, there will be a subgroup like MLA, MLC tower. There are about 12 towers under this particular MLA, MLC group. And under that group, a that is indicated with a subgroup like tower 1, 2, 3, like that. There will be 12 towers. So when the relocation engineer select one tower, then he has to say, for example, it is a tower 4, then he will enter the location of floor. In G plus 12 floors, he can enter, say, floor number 2, good unit number 3 or 4, like that. And he will come across the next nature of non-conformity. Like the nature of non-conformity is nature of observation is going to make whether in formwork, workmanship, floor tiling, concrete, reinforcement, or grouting of tiling, or n number of factors. There will be around 20-30 nature of non-conformities we have defined in the applications. Then from that he has to select whether in, so for example, in under workmanship he has come across with the observation and then type of observation he has to either make a type about that what defects he has identified. If you don't find that subgroup within that type of observation, you can record the type of non-conformity through voice record, or make some notes about that particular observation. Then there will be one more option whether it is a good routine or bad. So good observation will also be allowed to be uploaded. And as well as the routine is nothing but a repetitive kind of observation that he comes across. So he can record as a routine type of observation. Then the other one is a bad. So then once all these activities are completed, he can take a photograph and upload. So this gets stored in the server. all this data gets into the server. From the server, we can create a weekly report or bi-weekly report for each and every package separately that is executed by a different EPC agency. So how the data, see, this will be the interface of the user-based application as QScan. We call it as quality scan, is named as QScan, mobile and web-based application. This is the type of interface that is developed and which is installed in the mobile application, or it can also be in tab, also it can be loaded. For example, this is a model observation which is shown here, made for a color quantity, farmer and rebars. So color quantity is we have installed different types of colors for the power cable, data cable and other types of cables that is inside installed before concreting. And in farmer also there will be different kinds of observations, non-conformities that will be recorded and reinforced. All these will be there within the QScan mobile application. This becomes very easier for the in-location engineer to record and upload the observations. So how this quality audit using this QScan help the stakeholders? So it ensures compliance with approved drawings, specification, boards and statutory requirements. Data from QScan helped us to analyze the deliverable quality of PMC and EPC agency. So actually the PMC is one which is above the EPC agency. It's also a monitoring agency like us, but our role was below the client, APCRDA. So we report directly to the client. So under us, PMC agencies were for each package, and EPC was the executing agency. So the QScan data provides documented evidence for decision making, dispute resolution, and regulatory approvals. So the audit observation in NCRs act as structured learning tools that transform quality issues into opportunities for improvement, ensuring sustainable, safe and reliable infrastructure delivery. Protects stakeholder investments by controlling cost overruns and preventing premature deterioration. Improves safety, durability and performance of buildings and infrastructure assets. Enhances transparency, accountability among client, consultant, contractor and vendors. So it also increases the asset value, service life, stakeholder confidence and through assured quality outcomes. But above all, the back data helped both the client and the EPC agencies to make more analysis with the data that is available and recorded from various projects on each aspect of quality. Like as I said earlier, nature of the conformities. What type of conformity, more number of observers for each EPC agency, and this is also, this records helped the EPC agencies to train their relocation, train their site engineers and made them to educate and bring down the observation at a later stage when we, after implementation using this QScan application. This has helped us a lot in decision making. So next topic is conditional assessment. So normally conditional assessments are taken up for any existing infrastructure utilities or buildings after they are put into service. So in our earlier study we discussed about quality audit. Quality audits are taken up during the phase of construction to monitor the quality as well as other activities that comes under the audit. So that also helps the client to ensure that every aspect of the construction and activities are carried out as per the code of provisions and the client requirements. So, in infrastructure utilities like bridges, offshore structure, industrial buildings currently in service were designed for a certain loading standards, different usage patterns, and certain service life. Over time, factors such as material deterioration, environmental exposure, construction deficiencies, and unauthorized modification can significantly alter the structural performance. So this auditing, this conditional assessment help us to assess the structure and the deterioration of the structure's performance. But the current system is by means, there are other methods like it's the use of BIM and digital twin help the new coming up infrastructure utilities to be installed with some kind of sensors to analyze the deterioration of various parameters in the concrete structure and other structures. So by means of health monitoring. So what this conditional assessment actually provides? So presents evaluation of the structure with respect to various distress on whether it is cosmetic or structural deficiency, and the residual strength and service life, performance-based data-driven engineering judgment. So structural performance and decision support. Conditional assessment gives our present structural performance and decision support. Together, the quality audit and the conditional assessment enable defensible life cycle oriented engineering decisions. So this is the second case study which I have taken for conditional assessment. Actually, this particular structure building was designed for a G+9 floors. After completion of 3 floors, the management decided to start the academic classes. It is an institution building. The contract agency executing the job was made to speed up the activities and complete up to 3 floors before completion of the subsequent upper floors. So during a routine inspection, the field engineers and the technical advisors of the client came out with some distress in the structural elements and partition walls. So there are some different distress. What they observed on the site, they brought us to our knowledge, and our team was called to do a quality audit and publish a report. So our team engineers made the initial inspection, carried out few testings, and we found that some deviations in design standards were not being implemented during execution. So when the initial study was made, we found out some distress on the structure, and we decided to take up a detailed investigation on the structural concrete elements, and also decided to do some detailed chemical analysis tests, and the management also decided to entrust the work to us, and they are convinced by the first initial report that was given to the client from our basic study. See, in the detailed investigation, this is the methodology we follow. The visual inspection and the documentation of the earlier contract, documentation of the execution. That is what all the contract agency has maintained during the construction stage. That was given to us for verification, and we also found that some deviations were there. on the field test that we conducted, the laboratory testing and analysis and interpretation of test results, findings and conclusion. This is all the methodology we went through to take up this conditional assessment. The other side, what is the requirement as per the design standards? The grade of concrete to be implemented was M30. The minimum cement content to be adopted was 380 kg per meter cube. And cube strength as per the design mix has to be 39 Newton per millimeter square. The grade of steel proposed by designer was Fe 500. The grade of steel used was Fe 550. Density of concrete to be adopted was 2460 kg per meter cube. But when we came up with the laboratory testing as well as the field test, we found that the findings from the scientific assessment study, from all the tests what we carried out at site, so much of deviations were observed in all the categories of tests what we have done at the structural concrete elements. And drive density was observed to be lowest 2250 to 2390 kg against the design standard of 2390 kg per meter. That indicating an improper compaction, inconsistency in usage of concrete ingredients during the stage of construction. And compressive strength is less than the design mix concrete. The design strength was given as 39 Newton per millimeter square, whereas the strength what we achieved was in the range of M20 grade concrete. We were not able to achieve the design strength of M30. And from chemical analysis test, we found that the chloride content from the sample is found to be on the higher side. Normally, the chloride content should be 0.6 kg per meter cube, but it was found to be on the higher side than the design standard. And the cube strength there was much variation. As actually we took some nearly 20 samples of core, and that was tested for the compressive strength, and the variation was found to be wide. Consistency was not maintained during the course of construction, so that indicates why that was a variation. The consistency was not maintained during the construction phase by the executing contract agency. So considering the spread of concrete strength of core sample, the in-situ strength was considered as M20 for all purposes. This is a plan actually. Then actually we also found that subsequently the design what was done by the earlier by the agency, by the client, was found to be inadequate. So we decided not to go further with the higher floors. Above, actually, by the time when we were called to inspect and do the auditing, ground plus 3 floors were completed. But as per the testings and other the redesign, what we carried out the design vetting and found that the design was also inadequate. So we advised the client not to go further beyond 3 floors. So when we analyzed, we found that the structure cannot stand for 9 floors, what it was designed for earlier. Then subsequently, we identified, during multiple iterations of analysis, we identified that nearly 17 columns has to be strengthened to withstand even the 3 floors that is constructed. So the client has to spend a huge amount of money for strengthening the existing columns that were completed earlier. Within 1 year, all these sequence of activities happened. So we decided to go for strengthening, and the client was also approved to go for strengthening. Then we did the retrofitting by means of removal of plastering and by carbon fiber wrapping. This is how the sequence of activities: removal of the plastering and 2 layers of carbon fiber wrapping was carried out for all the 17 columns that was identified for retrofitting. This is how this conditional assessment study was carried out. And finally, after completion of this, the building is now under service condition. So, this is how the audit, conditional assessment study was carried out for this institution building. So there is a saying in Tamil, "Taram kakin tolil nilaikum, tavarin valarchi talarum." So as per that, I will hand over my subsequent main part of the lecture on quality. That what I have taught conveyed is quality auditing, conditional assessment, using some applications and how we got implemented. This quality is just not for existing building, and quality should come from design. That is our findings. And in this regard, I will now invite my team engineers, one Mr. Gokul and one Mr. Manoj Kumar, to share brief insights on integrating the current technology of BIM and digital twin in the above domains like quality audit, conditional assessment, and other areas starting from design, construction, lives of the structure, service until even they can monitor the service condition of the structures and utilities using this current technology. So now, thank you. If any questions are there.
Sir, this Amaravati is ready for occupation?
No sir. Sir, it was told that during 2019 when the new government, then government formed at Andhra Pradesh. Now it has restarted about 6-7 months back.
How long it will take?
Maybe another 5 years. Sir. All the works has to be retrofitted since all concrete works, sir. All the activities were under very worst condition. Since that is as such it is left over for the last 5.5 years. So we again we were called to redo all this auditing works to analyze the existing strength and condition of the structure. We have given the report, but now I think other agencies are being called into service to take care of the quality auditing. I think the
40-floor building.
yes, we completed up to 3 floors. It was a composite structure. The center core part is a concrete one. The outside was a steel structure. So we, by the time when we came out, it was 3 floors only got completed. Hopefully by this time they would have restarted the work, sir. Thank you.
Sir, this here oil and gas installation, especially piling. The offshore piling, basically the oil and gas, they are piling. But you know, the divers goes out and check only the limited.
There is a pile integrity test, one kind of a test that can be used to analyze the if there is any discontinuity in the concrete while laying the concrete. That can be found out, sir. There are now new methods and technologies available in the market to check after concreting the piling.
You have done any offshore work like that?
Offshore, we have a team of people to do that, sir. We have done it for Amaravati, even for some of these structures we were being assigned to take care of this testing of piles. After casting the piles, we were asked to do that.
So these piles are inside sea?
It's side sea. Definitely we can take it, sir.
Okay.
We'll be there, sir.
Okay, thank you.
Welcome, sir. So now Gokul will give more insights about BIM and digital twin technologies that are used for this new construction as well as even for quality auditing and for conditional assessment study. That can also help us to monitor the health after construction and after implementation. That is when the structures or utilities are put under service, we can monitor across the board. Thank you.
Thank you, sir.
Good evening, colleagues, and I'm Gokul. In traditional constructions, we often treat quality control as a site-based police action. So, inspecting work after it is being done to catch errors, but in a modern engineering, we must discuss how this to be pivoted for the quality assurance. So, a QA which happens in a design phase, it is a process of preventing defects before they manifest. Today, we will explore how a digital-first approach ensures that the project delivered is exactly the project design. So, I'll move to the slides. First, I will go over design and engineering services. We work with multidisciplinary analysis with a precise design and analysis across all building systems, including architectural design integrations, structural engineering optimization, and as well as MEP and fire protection systems. So here in the QA, with the precision of initial analysis, our design and engineering services provide accurate analysis for architectural, structural, MEP, and fire protection systems by performing these rigorous cross-disciplinary checks during the design phase itself. So we establish a flawless technical baseline. So this is your first layer of quality assurance, ensuring the design itself is physically and as well as technically viable before it leaves the desk. Next, I will come up with building information modeling and virtual design constructions. Here, we then move to the BIM and VDC services, which acts as a primary tool for virtual quality control. By creating 3D models and coordinating all building, industrial, and oil and gas services in a virtual environment, we perform automated clash detection. This is the pre-construction QC, where we resolve spatial conflicts in the digital twin so that the physical execution on-site is very seamless, reducing field cutting and also structural compromises. The 4D planning, which is an auditing the process. Here, the quality is often compromised by sequencing. 4D planning and scheduling allows us to visualize how the construction sequences are for optimal efficiency. From a QA perspective, this is a process audit. By stimulating the time, as well as we identify the trade, stacking and logistical risk that lead to rush. So this can also lead to low quality craftsmanship. So we ensure that these schedules supports the standards we have set. And then the 5D cost estimation, which is financial quality assurance. The 5D cost estimation is essentially financial quality assurance for providing accurate quality takeoff and real-time cost analysis. So we estimate the budget ambiguity that often leads to late-stage maintenance substitutions, as well as when the budget is fixed to the design reality, the engineer is never forced to compromise on any sort of technical specifications due to unforeseen cost overruns. And then we also work on the heat mapping, which is also called as performance validations. Quality isn't just about the strength, or it is about performance. Heat mapping is our tool for building science validation. We analyze every energy performance and optimize the building systems during design stage. This ensures that the asset meets all its performance theory metrics and also it has a comfort sustainability, and as well as the efficiency, ensuring a high quality environment from the end users to top. And we move to the 3D visualization, which is also called as the stakeholders quality assurance. So the misaligned expectations are the enemy of quality. So the 3D visualization and rendering provides immersive photorealistic renders for the stakeholders' agreements and engagements. These ensures that total alignment of the quality of finish and design intent. It is a visual quality assurance that check that prevents repeat construction design changes, which are leading to the cause of failures on site. These are the 60 BIM, the Building Information Modeling, which is also called as life cycle management. So our commitment to quality extends to the life cycle through facility management, and we optimize the operational efficiency and the life cycle management by handing over a data-rich model to the owner. This enabling QA ensuring that the building is maintained to an original design standards throughout its functional life. And we move to the conversion and utilization. In other words, we call it as retrofitting. So here in the retrofitting, our commitment is to the quality extends to the life cycle through all these, and for an existing assets, we apply conversion and utilization, and this involves structural optimization, adaptive reuse, as well as energy optimization. Here, our QA process involves audit on old structure and applying all the modern engineering standards to ensure this is continued safety and sustainability impact. And we move to the sides of project management and consulting, which are the guardian of standards. Finally, the project management and consulting provides the optimized cost control and construction management required to oversee the entire QA and QC framework. We are the guardians of these design intent when we integrate these 9 services. So we don't just check for the quality at the end, and we engineer it into the project from day one. And I have two sort of video. One is for a data center as well as one for a digital unit. So yes, in this video we can see how the project is started from day one and how it is being executed, including all the MEP systems and all other regions of what are the project we need to do in this. And then we have another slide of a digital twin. This digital twin is a framework which has been run associated in Dubai. So here it controls all your economic indicator performance, including your environmental cost stages and how much is the occupancy rates which the building holds. This is an Unreal Engine where it also shows us how it is operating efficient and economically. Here we can have a walk around of a children where we can see how the children is day-to-day operating, and it can be viewed in the place of where stakeholder he is in. When we walk through, these are the dashboards we capture, the electricity which is getting produced there, and there is being handled, and it has two metrics. If it is in a good way, above the metrics which we set up, it goes green, and if it is below, it goes red. As well as, we also have the water capacity which it goes, the light intensity which it captures, and also the temperatures, the air quality through environmental monitoring systems. We can also add these models. These are the models which are very dynamic bill, and then we integrate this into the digital bill. This digital bill aggregates all these things. Thank you.
Yes, sir. When you talk about digital twin, you are completely right? The digital twin also upgraded with the latest information, like every day, whether the performance is integrated in your product. Everybody has to walk around every day to update and have a comparison. How it is?
No, it will be on a real time. We will be integrating all the sensors. It can also be captured through CCTV and all other systems which we use. So it doesn't mean that you have to go and walk around using all the Internet of Things system. We can have this system in Internet.
This is a real project you are this is
This is an answer.
This is an answer.
This is an answer.
Okay. What will it uses digital twin? What will be the performance improvement you expect?
Okay, I have a digital expert with me.
Yeah,
also asking.
Like typically we use 30% performance improvement which we are seeing right now.
So this is an estimate or this is a
No, it's a real thing.
Okay.
Because for one of the colleges in Chennai we are doing it and we see those changes which are happening.
What you have achieved?
Yeah.
What you have achieved in your project?
Like quality, apart from that, asset life management and efficiency of the things we are achieving. And structurally, we have integrated sensors so we can monitor what is happening in structures after construction.
So somebody has to monitor it every day? What is
Whenever you are opening it, it will automatically get updated. It's not like we have BMS systems, which is already there in our building, so it manages everything for you.
BMS or BIM?
BIM is a tool which is a process which is used to create all the things visually. BIM system is installed in the same facility to monitor everything.
Suppose somewhere there is a structure that you get an indication that who will take it?
It will be prompting triggers to who has to take actions. Like if it is a structural engineer who has to go and sit over there to understand what is happening in the structure, that guy will go and sit over there.
Like the modern buildings, like 40 floors.
Yeah. That is the issue that it is not happening from the same perspective. So, but it will give you triggers. Instead of analyzing it at a later stage, we will be setting parameters like reflection of the beam should not exceed this extent. If it is exceeding the extent, it will automatically do this.
What I was asking is, what will be my cost benefit?
If you are asking about ROI, we feel like it is around 15% which we are currently getting.
Okay, thank you.
Thank you. Any more questions? Yeah, simulations we are getting over. For earthquakes, we work on historic areas, not on live areas because of if it is happening, we cannot get it. But the historic areas are really simulating what is the maximum we got there is a succession of earthquake results in our overall research strategy, but it is very negligible.
We sincerely thank Mr. Kalani and Mr. Mahboula for your insightful and informative presentation, auditing, and assessment of infrastructure and building. So your expertise and the practical insights about manpower physical case studies and use scan, which gave us a valuable takeaways to reflect upon and apply in our professional practices. We truly appreciate the time and the valuable perspectives you shared with us today. It is now time to felicitate our distinguished speaker. Before we begin the felicitation, I request Mr. Balasubramanian, ex-General Secretary, Mr. Radisson, Joint Secretary, and Mr. Kumar, Joint Secretary IT, to kindly come up on the stage. May I invite Mr. Balasubramanian to felicitate Mr. Kalani with a shawl as a gesture of gratitude. May I invite Mr. Kumar to felicitate Mr. Kalani with a garland. May I invite Mr. Kumar to felicitate Mr. Kalani with a memento in recognition of his stellar contribution. Thank you, sir. May I invite Mr. Balasubramanian to felicitate Mr. Mahboula with the shawl. May I invite Mr. Kumar to felicitate Mr. Mahboula with the garland. And Mrs. As we conclude today's technical inauguration, we would like to extend our sincere gratitude to our distinguished speakers, Mr. Kalani and Mr. Auditing, for sharing your valuable knowledge, practical insights, and professional experience with us. Your sessions truly added depth and value to today's program. We are also deeply thankful to our chief guest, Mr. Dhari Al-Ajmi, for his gracious presence and for honoring this important occasion with his time and support. Our heartfelt thanks to all the attendees and the tech members for your active participation and keen interest throughout the session, which made this technical inauguration engaging and meaningful. We sincerely appreciate the dedicated efforts of tech committee members and the organizing team for their excellent coordination and commitment in planning and executing this event successfully. We once again thank all our staff sponsors whose continuous support propels the successful journey of tech. We thank our today's event partners Amith and Eaton and Golden Park. We also thank our presenting sponsors CMFC, Golden Park and Blue. Our sincere thanks to our platinum sponsors Mahboula, Al-Architect Engineering, Cook, Sadako and Radisson. We are grateful to our board sponsors Al-Architect Trading, Al-Malai Sage, Durgan Bank, Eagle Government, Gulfstick, East School, and Mahata Trading and Building Services Company. Finally, we thank our silver sponsors AGDC, GDC, RAM, Sarana Government, Old MV, and Malala Roads and Events, and our partner Shifa Jessica. Thank you all for your support and for being an integral part of this technical innovation. Dear participants, please note that the survey questions will be posted in the app right now. Kindly take a moment to fill them under the list. And with that, it is now time for dinner and gathering. Thank you.
lot of